much time. Nope. Got a 15-minute block. I don't have time. Algebra is about finding the unknown. So in math, all of the time, there will be things that we need to find that we don't know. We use variables. I'm not going to call them variables. What's a variable? Oftentimes they're letters. This is going to be this block down here is letters. They don't always have to be letters, though. This blank up here is symbols. Often those symbols are letters. They don't have to be. I've seen students solve problems using pictograms. Symbols could be anything. Symbols could be the letter X. This is a symbol that has meaning. This symbol means what? It looks like a smiley face. Is it a smiley face? Is this a beautiful picture of someone's smiling face? No, it's a semicolon or it's a colon and a bracket that we use to say, this represents a smiling face. This is a letter X. I mean, we made this up. We gave it a particular sound. In English, it sounds one way. In Russian, it sounds another way. These symbols are just, they're given meaning. They're abstract. And so in math, the problem is the same. Dilkron, what are you doing? That's not what you were doing. How old are you, Dilkron? How old are you? Keep your hands to yourself. These are conversations I'm having with my 3-year-old. So even 12 isn't, kids these days. Keep your hands to yourself or I'll put you somewhere where you can't touch anybody. So algebra is finding the unknown using symbols and mathematic operations. Your standard operations, adding, subtracting, multiplying, dividing, but there's more. There's powers that we've used. There are many more that you haven't seen yet. In this unit, those symbols are going to be letters. In my mathematical career, I used lots of different letters. I've blasted my way through the English alphabet, the Greek alphabet. I've used half the Hebrew alphabet. Sometimes you just need more letters, more symbols for things we don't know. You guys are going to start with the English alphabet. And the letter that you guys are always first introduced to that represents an unknown is the letter X. X is always the first one. Then the second one is always Y. Yeah, then we move to some nice ones, things like M and N. P is good. We don't like O because O looks a lot like 0. Some of these variables have meaning. That's why when I say I've used multiple alphabets to do all this, as you guys start to advance further, these things have meaning. The reason we use X and Y is because they form the basis of the Cartesian coordinate plane, which we're going to talk about. That XY grid, which we're going to work with. Sometimes we use T, because T is the first letter in time. And if time is something we're looking for, we'll use a variable to represent that. So T for time. Things like D for distance. V for speed, except we're not using the word speed, we use velocity. So letters have all sorts of predefined meanings in all sorts of different contexts, which is why we have so many of them that we use. Not every unknown needs to be X. So in this unit, we'll use letters to represent an unknown value. The value is the thing we're trying to find. The value of the unknown is allowed to change. And because it's allowed to change, we say it is allowed to vary. And so we call these things variables. For example, let's say you're preparing pasta. This is a problem that regularly shows up in my home. I don't, given a certain number of people, how much pasta do you need? So if you know for one person you need 2 cups of dry pasta, which seems like a lot, maybe you really love pasta. If you have 2 people that are going to eat the same amount of pasta, how many cups of dry pasta do you need? 4. If you have 3, you're going to need 6. If you have 11, how many cups of dry pasta do you need? Specifically, 22 of them. How did you do that? Each one of these things, but why did you double it? You're double, you need 2 cups per person. So it's the number of people times 2. So we've got some variables here. What are the unknowns in a problem like this? One of the unknowns is what? Okay, there's an awful lot of conversation not related to what we're talking about here. The number of people and the number of cups of dry pasta. Well, the total number of cups of dry pasta. So we don't know the people. I don't know. Okay, guys, Jackson, don't start. Way too much conversation going on here. Unrelated, Emma and Brielle. So we don't know the number of people. And we don't know the total pasta. But we do know that we have 2 cups of dry pasta. So we could set up an equation to solve this thing. What is a variable we could use if we don't know the number of people? Jackson. We could use the number P, P for people. Let's call this thing P. We don't know, there should be the word no in here. We don't know the total pasta. So we could call this. It's not, it can't be P again because we've already used P. I heard someone say T, T for total pasta. We could use A for, it's the second letter in asta. So we could use an A. But I heard T first, so let's use T. We could say that the total number of pasta, and it's going back to what Gershon over here said. The total number of pasta is going to equal the number of people, P, times 2, because it's 2 cups per person. These are our variables. And we're not going to solve this chapter. We're going to wait a couple chapters till we can solve this. This is relatively easy to do. It is. So let's take it. Today is all about language. We're looking at polynomials. Hands up if you've heard this term polynomial before. One of you, a few of you. Fantastic. This word polynomial means what? It's a compound word, yeah. Many. Poly means many. Nomial does not mean number, Ruben and Gershon. Gershon, do you need a writing utensil? If you hadn't moved, it wouldn't have hit you in the head. Hayden, are we good? Okay. Poly means many. Nomial does not mean number. Nomial means term, someone just said, and they are correct. An algebraic expression is made up of, well, they might not be, several, is the word I'm going to use there, made up of several terms. A term is a portion of an expression separated by an addition and subtraction sign. So if you don't see any addition or subtraction, you've only got one term. For example, 15. How many terms are there? Do you see an addition subtraction sign? No. So how many terms are here? 1. 15 is one mathematical object. How about the letter X? That is also one term. But if I take those 2 terms and I add them together, how many terms do I have now? I have 2. 2 distinct terms separated in this case by addition. This guy down here, 15x, if I take those 2 terms and multiply them together, how many terms do I have now? A term is a mathematical object or mathematical objects separated by addition and subtraction. So because I have no addition and subtraction here, this is still one term. So how many terms do I have here? I have 3 there. Absolutely, Marcus. How many terms do I have here? You betcha. 2. How many terms in the third one?
Would the exponent be like 10?
Terms are things that are separated by addition and subtraction only. So even though this thing is squared, that doesn't change the fact that this is still one term. So how many terms do I have here? 3. Because I have one object minus a second object plus a third object means I have 3 terms there. So then this guy down here is 4 terms. Cool. We have special names for polynomials of 1, 2, or 3 terms. A one-termed polynomial, we use a prefix for 1. There are 2 prefixes for 1 that you should be familiar with. Mono is 1, the other prefix is for a single object. If I have 1 of something, 1 is either going to be mono or uni. Like a unicycle is a cycle with 1 wheel. You're looking way too happy to be focusing on the math. Is that's the problem. No talking to Delgran. And mono, if you have a pair of glasses with only 1 lens, that's a monocle. So both of these prefixes are used to represent 1 of something. This is the one that we're going to use for the polynomial, a single-term polynomial. And we're not going to write mononomial. It's just going to be mo, and we're going to borrow the no from nomial. This is pronounced monomial. And an example of a monomial from up here is, sure, 15. I saw a hand over there, yes. No? Okay. How about 2? There are 2 terms that we use as prefixes for 2 of something. They are, one of them's die, and the other one is, if I have a cycle with 2 wheels, that's called a bicycle. So the 2 prefixes that are available for 2 or something are bi or die. Bi is the one we're going to use. So a 2-termed mathematical object is a binomial. And a binomial, an example of a binomial is 15 plus, not 2, because 15 plus 2 is 17, but 15 plus x. If you can't, we need to make sure we can't immediately solve the thing. Why are you, Gershon, put your phone away. Why are you on your phone? We're getting a little loose with the phones, guys. A 3-termed object, I know of only 1 3 prefix. It is tri. Like a trident, the 3-pronged fork of the sea. No, tribe is a terrible example because a tribe has many people, and tribe is not a compound word. This is a trinomial. Someone give me an example of a trinomial. Yes, Juna, your hand was first. Minus which? Sure. Above this, mono, bi, and tri, there is no special term. So we call everything beyond that a polynomial. Polynomial is the catch-all term for any kind of multi-termed expression with more than 3 terms. When you're ready, flip the page. More definitions. We could call it a tetranomial, but we don't. We could have tetranomials and pentanomials and hexanomials, but we don't. We do not. So let's rattle these off. A pentanomial. How many terms do I have here? 2. So that thing is called a, you betcha. I will not wait. You must catch up. This thing is called a, sorry, how many terms in here? 1. So it is a monomial. This next one has how many terms?
3.
You betcha. So it's a trinomial. So, Karan? Hayden? How many terms here, Hayden? Glenn? Thank you. Dilkaran? Really? Okay, so Hayden, you have not, did you really not know how many terms were here? Terms are separate, it is 2. Terms are separated by addition and subtraction. There's one addition sign, so I have 2 objects being added together. So, Dilkaran, what do we call a 2-termed object? A what? A binomial, thank you. This has how many terms? 4, so we call it a polynomial. And the last one, how many terms? So it's a monomial again, good. Love it. Let's keep marching along. Some important definitions. There are parts now to terms and to whole polynomials that we're going to discuss. The first part is called the degree. Now, the degree isn't going to be useful until later. Later, as you get further on in mathematics, all of a sudden the degree is going to be something, Hayden done, that is going to give us information about how a polynomial behaves. At this stage, we are not equipped to talk about how the degree impacts the behavior. We're just going to identify the degree. So the degree of a term is the sum of, there should be a word in here, all the exponents on the variable of a term. Now normally, in the exponents chapter, you could only add exponents if the bases were the same. That was when we were combining bases. Here, to find the degree, we're going to take all the variables and we're going to add up all of the exponents on the within the term, and that's going to tell you the degree of the term. So, what's the exponent on the x squared? It is 2. Some of us were not able to identify this yesterday. So if the exponent is a 2, the degree then has to be 2. That's it. The degree is the sum of all of the exponents on the variables. If there's only one variable, it's just the degree. So what's the degree here? 1. Good. Because when there is no exponent written, the exponent is a 1. What's the degree here? It's just 2. There's only one variable. It has an exponent of 2. How about this one? Yes, Andrew, it is 3. Because the y has an exponent of 1, the x has an exponent of 2, you add those together, you get 3. How about this one? It is, in fact, 5. And this last one is? Someone said none. What's the mathematical term for none, or the mathematical value for none? 0. You are correct, it is 0. Juno, you want to explain why? There are no letters, yeah. There's no variables. Dilkaran, yes. There's no 1 where? When there is no 1 written, Dilkaran, it's assumed to be a 1. Okay, so that is the degree of a single term, Gabe. The degree of the polynomial is slightly different. To find the degree of the polynomial, it is the largest degree of all the terms. So you have to find the degree of each term and then just tell me which one's biggest. So let's do this. How many terms do I have here? I have 2 terms, so there are going to be 2 different degrees on those 2 terms. The degree of the first term is 0. The degree of the second term is 2. So which one's bigger, 0 or 2? Thank you. So the degree of the entire polynomial is 2. How many terms do I have in the second one? There are 3 of them. So there are going to be 3 distinct degrees for those 3 terms. The first one, the degree is. The second one, the degree is. And the third one, the degree is. So the biggest number there is. So for the whole polynomial, the degree is 4. The biggest of those 3 individual degrees. The next one, degree, how many terms? 2. So the first, yes, someone said it. Jackson was rushing ahead. Jackson, you got one of them correct and one of them incorrect. Was a voice coming from beside Jackson then? I don't know. Liam? The first one was correct. The degree is 2. The second one you got to be careful with. It's not 4, it's 5. Because you need to add to it the exponent on the y. When there is no exponent written, it is a 1. 4 plus 1 is 5. Yes, Dilkron, I saw that hand. So the total degree of this polynomial is 5, because 5 is bigger than 2. The last one has how many terms? The degree of the first term is? The second term is? The third term is? So that whole polynomial has a degree of? Done. Love it. Questions, comments, concerns about what I've just done? Okay. 2 concepts left, and then I'm done, which is good because I think class is done soon. Class ends, yeah, these 15-minute blocks are short.
What time is it?
15 minutes. Okay, here we go. So the last 2 pieces are the coefficients and the constants. Hands up if you have heard this word coefficient before. Fantastic. Hands up if you can explain to me what it means. Jackson, what is a coefficient? You have the right idea. Yes, it is coexisting. What is coexisting with what? Raven, those are my favorite cheesies. Excellent choice. Yes, the numbers and the variables are coexisting with each other. Variables have names, so it's the other piece that we call the coefficient. It is this blank, the and the should not exist. Scribble that off. The coefficient is the number in front of a variable. When we say in front, how are they attached, the number and the variables? The number and the variable are attached with, if it's just sitting in front, someone said it louder. Multiplication. So the coefficient is the number multiplied in front of a variable. So when there is no number written in front of a variable, the number is assumed to be 1. So the coefficient on this guy is a 1. There are 2 terms here. Both have variables. So there are going to be 2 coefficients here. The first coefficient is, and the second coefficient is, it's not 1. It's -1. When you've got multiple terms, you need to include the sign in front. So if there was just a minus sign there, it's going to be -1. Yep. So what are my coefficients here? There are 2 of them. What are they? -1 and 1. Very good. I am going to change the last one, and I'm going to add a 5th one. So add a little box to the end of this row. I'm going to change the question. Instead of x plus 5, I'm going to make it 1/3. X plus 5. I'm going to zoom in here so everyone can see it more clearly. 1/3x plus 5. And then the last one, I'm going to write just x divided by 2.
Divided by 5.
Yes. Now, coefficients are the number multiplied in front of a variable. So what's being multiplied in front of the x here? That number is 1/3 or 1/3. Fractions are numbers too, even though you hate them, you mathists. So the coefficient here is, fractions are not stupid. What's the coefficient here on the 1/3 x plus 5? It's 1/3. And this 5 isn't a coefficient. It doesn't have a coefficient because a coefficient means it has to be multiplied in front of a variable. There's no variable here, so we're done. The 1/3 is the only part of here that's a coefficient. And this last one, if I have something divided by a number, I have x over 2. Dividing something by 2 is the same as multiplying it by what? 0.5, or 0.5 is 1/2. So if I have x over 2, this is the same thing as 1 over 2 times x. Division and multiplication by a fraction are the same thing. So if I have x over 2, my coefficient there needs to be understood to be 1/2. Division is just a nasty way to write a coefficient. Absolutely I will. Because you need to understand what that means. Don't know, don't care. I'm teaching it to you, so you're going to learn it. Can you tell I've heard that a lot? It doesn't matter when you're going to use it in your life. You may never. But you may. And sometimes learning things isn't about when they're going to be useful. Honestly, sometimes trying to teach you guys useful things are the things you care less about. Because how many of you, I shouldn't take the poll. How many of you know how to cook? Not all of you, though. Oh, okay, that's not cooking. Boiling water is not cooking. You can make an egg?
I can scramble eggs.
Okay. Are you going to live on eggs and pancakes the rest of your life? So there's more to learn there. Useful, but you haven't done it yet. Okay? Not everything I try and teach you here is about giving you a concrete tool you're going to use every moment of every day. But teaching you these things, it flexes your brain, makes you a more intelligent human being. That you're going to use all the time. Dil Quran, I want you to take your stuff, and I want you to go sit at the table at the back by the air conditioner. Get up and go now. If you can't keep your hands away from Ruben, I'm going to move all of you away from Ruben. No, I already told you once not to, and I told you if you did it again, I'd move you. You did it again, so I'm moving you. All your stuff. Backpack too. Okay, here we go. There's your coefficient. Let's talk about the constant. A constant is the number that doesn't have a variable. And you need to include, get rid of that, the sign out front. Hayden, don't worry about it or I'll make an example of you too. Because I'm sure Jet Pete wants her spot back. So, 2 terms here. One of them has no variable. That term is -2. So that is the constant term. How about here? I have 3 terms there. Hayden and Gabe. Stop talking to each other. Is there a term with no variable? No. Every one of these terms has a variable in it. The coefficient is 1. But the question is, what's the constant? The constant is the number with no variable. Every single thing has a variable. So the constant is 0. Because there isn't one. The constant in this one is 7, because 7 is the number being added in there, subtracted in there with no variable attached to it. And the last one here is -1. You have to include whatever sign is out front. Okay, so that's all we're doing today. Just a bunch of terminology. I want you to flip the page. And I want you to crank out this page. You have 15 minutes, which is lots of time.
15. You said that like 5 minutes ago.
I was wrong before.
Oh.
It was 25 minutes before. Now it's 15 minutes.
11:30.
You do not need to do this on the whiteboard. There is no work to do. You're just reading it off.
Why is my
No.
sister on her phone?
No. At your desk, not at the couch. Crank out these 20 questions. On your mark, it said giver.